A lot of map projections that show the entire world are based on cylindrical projections, and specifically on the cylindrical normal projection, where the axis of the cylinder lines up with the axis of the Earth. And in this way, we have one line around the middle of the map that represents the equator, which will be a line of no distortion. But of course, throughout the rest of the map, we're likely to have distortion on these cylindrical projections because of the way that they occur. So this is probably the most famous cylindrical projection, the Mercator projection, and this shows the Mercator projection extended to close to the North Pole and to the South Pole. And we understand that this is a conformal projection where the shape of all of these features are not distorted, but of course the size of these features are distorted on this map. For example, Greenland here is not really as big as Africa, but because Greenland is at a high latitude, it's getting bigger and bigger. And we can also see that in the spacing of the lines of latitude as they get further and further apart, the further north that we move. Of course, usually with the Mercator projection, we're not seeing so much. We really see that distortion also in Antarctica. And the way sometimes this is typically dealt with is by just showing not so much to higher or lower latitude. So it looks like a more reasonable map of the Earth. We can see the cylinder has been wrapped around the globe here. This would be the line of zero distortion in any way. And once again, this is a conformal projection, but obviously not an equal area map projection. It is, however, possible to make equal area map projections of the world. And this is one example. This is a cylindrical equal area map projection. And we can see once again that the cylinder has been wrapped around in a normal fashion so that the line of the equator is touching the cylinder, and then we get more distortion, this time in shape as we move up in this direction here. Areas are equivalent. We can see now Greenland no longer looks so much bigger than Africa, but there is a lot of distortion in the shape of Greenland. Another example of a cylindrical map projection is this gall-peters cylindrical equal area map projection. And with the gall-peters, we can see that now they've stretched things out, the lines of latitude out more near the equator and less so as we go to the North and South Pole here. This is another example of an equal area cylindrical map projection with using a normal cylinder that's parallel to whose axis is parallel to the rotational axis of the Earth. So once again, this would be touching along this line here. That would be the line of zero distortion. And one other thing to note in all of these examples with cylindrical projections is that our lines of latitude and longitude are both straight lines perpendicular to each other. And one way to think about it is just the spacing of those lines of latitude that's influencing what type of map projection we have here.